Hello students and the warmer welcome in this next lecture of the thermodynamics. So today we will be learning the lecture number 10 of the thermodynamics chapter from the physics. So before we move ahead students, we will learn that which part we have learned in the previous lecture. We will just revise in short impact of time. So the first point we have learned from the previous lecture is the third case from the three of them, that the three paths were there of changing in state of the system. Out of that, two systems we have learned, then third system we have discussed in the previous lecture, and we will revise that one in the very short impact of. So students, we will look up to that diagram in a very short impact of time. So this is the diagram which we have learned, that PV diagram. You can see here, at first the title is at first the pressure changes at constant volume, then the volume increases at the constant pressure. So this is the PV diagram. At this point you can see the value of pressure is too high at the point A, and it is continuously goes on decreasing, and it will move towards the x-axis or towards the point PF, means the value of final pressure. Then it will reaches the value of the initial volume. Then once it reaches to the value of initial volume, it will be moving towards the final volume drastically, slowly. Thus this will be nothing but our work done, which is shown in the shredded area. So this is the third path we have learned in the last lecture of change in state of the system. Now after that we have discussed the diagram of heat added during the thermodynamic process. So this is the next part that we have learned after the third path following into the change in state of the system. So this heat added during the thermodynamic process is, as I will explain in very short. So you have to make an arrangement of cylinder and piston, and the piston should be massless, frictionless and movable. So this should be the condition of the piston, and in that cylinder there is gas has been enclosed, and this is the arrangement that we have done for the demonstration of the heat added during the thermodynamic process. Then what we have to do, at first at the initial stage, the gases inside the cylinder has no internal energy, means the very less internal energy, but hence there will be the no movement of piston upward or downward. But when you added this external source of heat, then what will happen? The external source of heat will heat the cylinder, and that heat will obtained by that gases enclosed by the cylinder. Thus the internal energy of that gases will goes on increasing. Thus this internal energy will gives rise to the motion of the gas particle will impact over the walls of the piston, and thus this is because of this impact on the wall of the piston will move in the outward direction, and because of this impact the piston will move outward direction. Thus there will be some work will be done, that's why the piston movement will be occur. So this is the heat added during the thermodynamic processes. So this process, students, consists of two stages. First of all, you have to explain the stage at which there is no source of heat is added to the gases which has been enclosed into the cylinder, means no heat source will be added to the system. And the second stage, you have to explain when the external source of heat will be added to the system, then which changes will be occur on the piston. So these two parts or the two stages you have to explain in this point, which are most important. So these are the 2 points that we have learned in the previous lecture. Now we will move to the next part of the lecture. Now students, the next article we are going to learn will be the pop on your screen. So this is the diagram or the article that we have to learn here in the next part of this thermodynamics chapter. So as you can see that the title is uncontrolled expansion of gas, means the title itself will suggest there will be the expansion of something, means from the initiation part of this chapter we are considering the gas. So there will be the expansion of gas which will be uncontrolled, means there will not be any control over this expansion. So this is the that part that we have to learn here. But during this process, which are the thermodynamic concept we have to learn during this process, we will learn in detail now. So here you can see the two cylinders. So in this case, the cylinder is surrounded by the insulating material and divided into two sections, as you can see. And two sections means there will be the breakable sections, means two sections will be there, but the partition between the two sections will be breakable, means at some condition, at some circumstances it is breakable is the condition. Now the arrangement is as shown in figure, means as you can see, I will explain now. In the first stage, the condition is same gas at normal temperature, means as you can see that at the first condition, the same gas is at the normal condition, means their internal energy will be very less as it is in normal condition. Now means they have given the normal temperature, thus there will not be no any rise of the temperature or the internal energy of the gas which has been enclosed into that cylinder. Now in second stage, when gas is heated by the temperature difference in uncontrolled way, means in the second stage they have given the information that we have to heat that gas in uncontrolled way, means there will not be any limit to heating that gas. So the volume increases and occupies the vacuum space also. So it is because of insulating material and no exchange of heat, which is called as a free expansion, no piston movement and no work done will be there. Means at first stage the same gas is there, but we are not heating that, the gas we are keeping it for the normal temperature. So as the gas is at the normal temperature, then there will not be any increasing internal energy. So as it will not be increasing internal energy, the gas will remain in the stable condition, means it will be below that partition which is breakable. Okay, so this is the first stage, students, means the x and y stages they have given. At the x stage, the temperature will be at the normal, and the y is the phase. Y is the phase means section x and section y they have given. Now in the second stage, what we have to do? We have to heat that in uncontrolled way, means there is no limit to heat that gases which are enclosed into the cylinder, means in that uncontrolled way we have to heat the gases inside the cylinder. Then what will happen? That gas will increase in its temperature drastically, thus the internal energy of that gases will goes on increasing. Okay students, so we have learned that as the internal energy of the gases will goes on increasing, the particles of that gases will move drastically, means randomly it will move, and it will try to exert the forces on the walls of cylinder, and especially on that part of the piston or that part of the portion of the cylinder which is breakable or which is weak. Okay, so thus the particles will try to push that partition which has been divided into the two parts as x and y. This particle is directed they have as a breakable, means the internal energy which of the gases will be able to break that partition. So the heating is in uncontrolled way, means there is no limit of heating, hence the heat will be goes on increasing, and this will further given rise to the increase in internal energy of the gases, which will further break that partition and which will occupy the space of y also, means the x which contain the gases will also occupy the space of y. Then the total space contained by that gas will be x plus y because of the uncontrolled heating. So the volume will be increased because of that external source of heating, thus the internal energy will be increased. So this will be the, but as you can see there is insulation is provided and the no piston arrangement is there, means that there is the absence of piston, so that there will be no movement of piston, hence there will not be no work done. So when we say that there is work done, when the piston is moving inward or outward inside the cylinder, On the basis of that, we are deciding the work has done or not, or whether it is positive or negative. But here is no piston arrangement is there, then we can say there is no movement of piston, there will be the no work done. So this is the condition which will be fulfilled, that there will be no piston movement and no work done in the process of uncontrolled expansion of gas. So this was the concept, students. Now we will move towards the next part of this chapter, that is classification of thermodynamic processes. So here in this part, a process by which the variable can be changed is called as a thermodynamic processes. Means students, a process by which the variables can be changed means what? Which type of variables are there? Let it be like a pressure, volume, temperature. So these are the few types of the variables. So there will be some change in those variables. Means let it be the initial pressure into the final pressure, initial volume into the final volume, and the temperature will be changed from the initial temperature to the final temperature. So these are some two stages of the each variables. So there will be change in that each variable. Then we can say a process by which the variables can be changed. So this is nothing but the thermodynamic process. So out of these, students, there are number of thermodynamic processes, but out of that we will learn the first one now. The first one process they have given is reversible process. First of all, you can observe the diagram of the PV diagram of the reversible process. As we have discussed earlier that the pressure is indicated on the y-axis and the volume is indicated on the x-axis, and the point A is given and it is in curve shape as it is moving towards the volume. So students, as you can guess that what will be the value of the pressure at point A, we have already saw a number of situations like this, means a number of phases like this. So at point A, the value of the pressure will be P1. Okay, so the value of pressure will be in increased state. So as the point A will move towards the at its point B, so what will happen? The pressure will be goes on decreasing and the value of pressure will be decreasing and the value of the volume will goes on increasing. So this will be in one direction, and in other direction when this process will be we have work done to take that process again into its initial position, then what will happen? Then again the volume which will goes on decreasing and the pressure will goes on increasing. Means the initial state and the final state will be attained, but the point at which the point at which the process has been started, again that same point will be attained by this process, and this is the nothing but the reversible process. Now we will see a reversible process is that chemical process in which the substance can be brought again into its initial state of phase from its final one. Means the state of the final point can be bring again back into the initial one. That process is called as a reversible process. For example, you can take the melting of ice. Means as the ice can be melt and it can be changed into its phase, means ice will be converted into the water, and again if we freeze that water, it is convertible into the ice again. So this is the one of the example, and the freezing of water. So these are the interrelated examples. Now boiling of water is one of the example. Again you can condensate it and again you can bring back into the water state. So these are the example that we can learn that what is mean by the reversible process is. The path of reversible process is same in forward and reverse direction. So this is the important characteristics of the reversible process. Means path will not be changed, the path will be remain same in the reversible process as in forward as and also in the reverse direction as well. Now the curve shows reversible expansion of gas with the reversible compression. Means the curve we have already discussed that shows the reversible expansion of gas with the reversible compression. Means the compression and the expansion will be taking the same path but in opposite direction. Now so this is the entire reversible process along with the its example we have seen. So this is the part of the lecture we have learned into the this lecture that uncontrolled expansion of gas as the cylinder has been provided with the insulation, and next one, the reversible process. So students, the next part of this chapter we will learn in the next video, but before that I will request you to revise some previous part so you will understand in the better way. So we will meet with the next part of this chapter in the next video. Thank you so much students.